Hey everybody, how you doing? I hope you're okay and your studies are going smoothly. It's time for some biopsychology revision, and today we're going to be looking at studying the brain. Here's a selection of exam-style questions to help you with your revision and practice. I would encourage you, if you've got the time and space, to pause the video in a sec, give some of them a go. I've put time limits there for you. Come back, play the video, and I will talk through my thoughts on tackling them. Okay. Right, let's crack on. Here we've got the command word identify. So even though it's a very generous time limit here, this is a question where, on the day, if you get something like this, you are banking a couple of minutes to use on more challenging questions later. So 4 techniques for studying the brain. There are many more than 4, but the 4 you're supposed to know for the AQA spec are fMRI, EEG, ERP, and post-mortem. Okay, for 3 marks we need to describe fMRI as used in the investigation of cognitive abilities. So that second part of the question tells us that we need to make some kind of link to maybe a task or kind of how it would work to study thinking and kind of maybe what bits of the brain even do. Okay, so it's not just a pure outline of fMRI. It needs to be linked to how it actually works. Okay, so fMRI measures brain activity by detecting changes in blood flow. Basically, when you're thinking, when your brain is doing something, your neurons, your brain cells require oxygen to do that. And they don't kind of like have a big store of it. So that oxygen has to come in from the blood. And fMRI, if you've ever been in one, you kind of know what this feels like, but you basically lay inside a giant magnet, and that magnetic field can detect oxygenated and deoxygenated blood. Yeah, they've got slightly different magnetic properties. So when oxygen is flowing into these neurons that are active, it disrupts that magnetic field, and the computer picks this up. Yeah. So in terms of describing how it works, it detects brain activity it measures brain activity by detecting changes in blood oxygenation using a magnetic field. This data is processed by a computer or by software and turned into coloured images that represent areas of brain activity. Okay, that's enough for a good couple of marks there. And what we need to do is, as I said, link to this second half of the question. So, for example, a participant might do a working memory task, a language task, whatever, just, make something up. And the areas of the brain that are active, according to the graphs, are therefore concluded to be linked to that skill. Yeah. So what you'd see probably is if you give someone a working memory task, you would see areas of the frontal cortex lighting up if it's kind of like an executive function type thing. You might see areas of the temporal lobes if it's a more kind of, recall type thing, or the hippocampus if it's a more kind of long-term memory or navigation type thing. But you'd see those different areas lighting up. Okay. Explain how postmortems are used to study the brain. Again, you're not just defining postmortems. So that second part of the question, how is it actually used? So a post-mortem examination is a detailed physical study of the brain after death. That's your kind of 1 or 2 mark definition there. For example, a patient with a particular behaviour during life, for example, maybe a condition like schizophrenia or a memory impairment or whatever it might be. So a behaviour, you would investigate their brain after they have died, and you would link any damage or abnormalities in the brain to that behaviour. Okay, for example, you're probably aware of Brocker's case study of patient Tan. So he found that there was damage to Brocker's area, so the left frontal lobe, and because Tan had the speech difficulties while alive, the idea is that that part of the brain is linked to speech. You wouldn't have to talk about Tan in this question. I'm just giving you an example to illustrate the point. Right, we now want to explain one difference between ERP and EEG. Okay, so EEG measures general or state brain activity, whereas, so you need that kind of comparative language in the middle there. Whereas ERP measures a specific response to a specific stimulus. Distinguish, again comparative language here, between fMRI and EEG. So you could distinguish them in terms of how they work. You could be a bit more evaluative and talk about things like how valid are they, talk about their temporal resolution or their spatial resolution, so how kind of accurate are they location-wise, how quick, or I suppose you could even talk about how expensive they are, but there's probably better points than that. So you've got a bit of a choice. For 4 marks, I'd probably pick 2 points and say fMRI does this, whereas EEG is like this. Okay, so what could you say? fMRI measures brain activity via changes in blood flow, whereas EEG directly measures electrical activity from the scalp. That's 1 point. fMRI has good spatial resolution, meaning it can investigate small specific regions of the brain, whereas EEG has relatively poor spatial resolution because it picks up activity from thousands of neurons underneath the electrodes. Okay, explain one strength of using EEG. Well, we've kind of just done a limitation there, but a strength might be that it, as I said, directly measures brain activity. Yeah, now what I mean by directly is we don't think in blood, do we? Neurons communicate electrochemically. Yeah, the actual action potentials, the actual signals coming down the axons of your neurons are electrical. So that's one of the problems with fMRI, but this question is on EEG. So a strength of EEG is that it directly measures brain activity. It picks up electrical signals from neurons via electrodes, and this means that it has internal validity as a method of investigating the brain. Last row. Discuss one strength of fMRI. So here you want to explain a strength and then give some development or some counter-argument or some kind of, discussion. So a strength of fMRI is that it has good spatial resolution. It can be used to investigate deeper regions of the cortex. It can be used to investigate small areas of the brain, something like that, which maybe makes it more useful than other methods. So that's the strength. However, and this is where the discussion comes in, however, because it's based on blood flow, critics argue that it is not a direct or not a valid method of studying the brain compared to something like EEG. There you go, done. Okay, for 8 marks, compare fMRI with one other method. In a way, this is very similar to the 4 mark just above it that we did earlier. Yeah, but the command word compare here for an 8 marker, what we're not really doing is just doing an outline of both, and we're not really just doing evaluation of both. So you need to kind of use sentence starters like one similarity between them is, one difference between them is, this is better, this is more appropriate, more valid, that sort of thing. Yeah. So think about which other method you want to do. It doesn't matter too much, but I'm tempted to do EEG because we've already talked about that. So one similarity between fMRI and EEG is that they can both be used to investigate cortical specialization, or just what bits of the brain do. However, they differ in how this works. fMRI is based on blood flow, whereas EEG is a direct measure of electrical activity via electrodes. This means that, arguably, fMRI is less valid than EEG as a method of studying the brain. A further difference between fMRI and EEG is in terms of their spatial resolution. fMRI can be used to investigate very small regions of the brain and deeper areas of the brain, such as the limbic system, the hippocampus, so on. Whereas EEG cannot be used to investigate deeper areas of the brain because it uses electrodes on the scalp, and they cannot pick up activity from anything below that kind of surface level cortex. Arguably, this means that fMRI can be more useful than EEG when investigating certain areas of the brain or certain functions. Now that might be enough if you've developed that, but let's just talk about one more brief point. A further difference between fMRI and EEG is in terms of temporal resolution. So temporal resolution is kind of how quickly you're getting that data. Is there like a big time lag? Is it kind of, are there breaks in what you're getting? Or are you getting like a continuous stream of data? That sort of thing, okay? So with fMRI, I mean, the technology is developing and we can use it to get kind of like a live, moving kind of coloured model, but it's not often used like that and it's very expensive to do it like that. So I would make the argument that really EEG does have better temporal resolution. You're getting a live kind of graph. I'm sure you've seen these kind of graph, like waves of the brain's activity. So that means it's got a better temporal resolution than fMRI. Okay, finally we've got a relatively straightforward 16 marker to discuss one or more methods. I've talked a lot about EEG and fMRI already. I might say a couple of things about one of the others in a second, but structurally all you're going to do here is it's 6 marks of knowledge, 10 marks of evaluation. You choose. If you think you can do 6 marks of knowledge on one of the methods and you've got a good 3 or 4 discussion points on that one method, go for it. If you think, oh, actually I'm not really sure, maybe I'd like to do 2, do that. That question is nice and open. It could be that some of your evaluation is a bit comparative and you're kind of doing what we did on the previous question. You don't have to. It could be that you treat it as basically 2 8 markers and you do a little knowledge paragraph on, say, fMRI, you do 1 or 2 discussion paragraphs on it, and then you move on to do a bit of knowledge on, say, EEG, and then do 1 or 2 discussion paragraphs on that. That's fine, but that's one way of breaking it down. Okay, as I said, we've talked a lot about fMRI and EEG. ERP is very, very similar in that it uses the same technique that EEG does. It's just that you will present the participant with one specific stimulus or task. It might be a noise, might be some kind of sensation, whatever it might be. And then you do that maybe like 10, 100 times and you average it out. Yeah, so you get that brain's specific response to that specific stimulus. We've already talked about post-mortem. So in terms of evaluation, you can use basically the same evaluation as EEG for ERP, because they're the same technology. In terms of post-mortem, it's the only one that is actually kind of a physical, detailed exam where you can actually, zoom into whatever you want and, dissect the brain that way. The others are non-invasive, which is good, but you can't actually get inside the brain unless you're doing a post-mortem in this way, yeah? Which means it can be good. But the problem with post-mortem is that it's all kind of after the fact, yeah? So you've seen, let's go back to patient TAM. You've seen that behavior, that speech issue in life, but you're not actually getting to the brain until, say, many years later, or certainly after death. And so there's a debate about, did the damage that you've seen in the brain actually cause the behavior, or did the behavior cause the issue in the brain? Yeah, it's only correlational because you're not able to establish that causal relationship in a post-mortem. Okay, right, hopefully that's enough ideas. Okay, reflection. How did you do? What do you need to do next? How easy was it? Did you manage to do it under time pressure? Feed that back into your next revision. Okay. Thanks very much, guys. I hope that was useful. Do drop me a comment or a question. Keep going. You got this. Bish bash bosh.